Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
In this problem, we are looking at the motion of two rockets. One is rocket A, the other is rocket B. These two rockets start out flying forward in the positive direction at two different speeds, but then slow down and reverse direction and end up, after a certain period of time, both at their same starting point at that same moment in time. So the pieces of information we know here is that rocket A has an initial velocity of 5,800 meters per second compared to rocket B's initial velocity of 8,600 meters per second. Then rocket A has an acceleration of negative 15 meters per second squared. And we don't know the time for either of them. However, we do know that the time that we're looking at is going to be the same for both numbers because they both intersect again at some certain point. And the interesting piece here is that at that point in time, we are looking for the moment where their displacement is 0, where they both have returned to their starting point. And our end goal here, what we're actually looking for, what the problem wants to know, is what is the acceleration of rocket B. Now, looking at what we have here, anytime you're dealing with kinematics, if you know 3 numbers, you can always solve for the other 2. So if our goal is to get the acceleration of rocket B, we need to know 3 other numbers for B's kinematic equations. We only know 2 of them. However, we know 3 things about rocket A, and we know the time for rocket A has to be the same as the time for rocket B. So this problem is going to be broken into 2 steps. The first step is finding the time it takes for rocket A to return to its starting position. Now, because rocket A, we want to know the time, and the only thing we don't know and don't need to know is that final velocity, we're going to be using the equation that does not have final velocity, which in this case is our last equation there down on the bottom, that x equals v naught t plus 1/2 at squared. When I plug in my numbers for rocket A here, we have that x value of 0 is equal to 5,800 t plus 1/2 of negative 15 times t squared. Now, this equation usually makes me a little bit nervous because it sometimes sends us into the quadratic equation, but because we have a t in both terms here, we can actually divide everything by t, and this simplifies down to 0 is equal to 5,800 minus 7.5 t squared. I'm sorry, just t, because we factored one out. And then to finish this up, we have 7.5 t equals 5,800. So the time it takes for this rocket to return to its starting position is 773.3 seconds. And because we know the time for both parts of these is going to be the same, that's also the time it takes rocket B to return to its starting point. So we know this time here is going to be 773.3 seconds. So step 2 is using the same equation we just did. We're going to plug in the information we have for B. So x equals v naught t plus 1/2 at squared. When I plug in my information for B, we have 0 is equal to 8,600 multiplied by 773.3 plus 1/2 A times our time of 773.3 quantity squared. So this has quite a few bigger numbers to calculate, so we're going to grab our calculators here. I'm going to subtract it to get things on their own side. We end up with negative, this is 6,650,380, which is equal to 29,800 996 times the acceleration. So I got that a little bit wrong there. It's 298,996 times the acceleration. And then we divide by that to end up with an acceleration of negative 22.24 meters per second squared, which is our final answer here.